All right, so here's my remote private cloud Windows 10 machine, and I'm doing this PMA 432. So I want to set it up for kernel debugging. And all right, we use CFF Explorer. So the first thing is take a look at NTOS kernel with CFF Explorer. So let me give that a shot. Open up File Explorer and go to C Windows System 32, I think. I can probably do this, huh? Yeah, good. Ignore their stupid GUI. And now I can find NTOS kernel. .exe. And there it is. So now I can right-click that and open with CFF Explorer. And now it will show me, it's a kernel, it's a portable executable 64-bit. The DOS header is, of course, a useless appendix. Here's the NT header, and here's the file header. And if I go to the optional header, and the directories, and eventually, here I'll find, this is what I was looking for, the export directory. And there we go. Now I see, I expected to find it there. Okay, let me take a look at my instructions. I'm looking for the functions it includes, and they'll be somewhere in there. Yeah, in the export directory, I should see them. There's a lot of functions, starting with, oh, I see, down here. I'll create security context. Okay, let me look at that. I just have to scroll down here. So, yeah, I see. This has a scroll bar. Okay, there we are. So ALPC, create security context, and get header size, and here's all the NT functions. Many, many, many NT functions, and that's everything Windows can do. Everything is ultimately a kernel function. All the rest is just things that call things that call things that ultimately call a kernel function to do everything. So that's the only point of this is so you see in one of our standard tools what the structure of the kernel is. It's just an executable with a lot of exports. So we're going to use BCDEdit for local debugging. So the first thing is to set this up. Now this machine is probably already set up for debugging. I'm going to assume it is and try to dodge this restart. Let's see. You need an administrator command prompt to do this stuff. All right. And now BCDEdit. I think if I do BCDEdit, it'll show me the current BCDEdit settings. And I think if I knew what to look for, I could tell if debugging was turned on right now. But I'm not seeing it. Anyway, I'm going to execute these commands, and I'll assume that they already have been executed, so I don't have to do the restart, and it'll tell me if I'm wrong. So it's BCDEdit. All right, that's right. That's the problem with my private cloud machine. It's a little bit like driving on ice. There's a delay in responding to my mouse motions, so there we go. BCDEdit / debug on, there we are. BCDEdit.
Is that for your PC at home?
What's that?
Is that your PC at home?
It is. Yeah, I got a server at home that's pretty powerful, and it's running a bunch of these cloud machines and using Proxmox. Proxmox is awesome. Learned about it from Caitlin. It's a Debian distribution you install, and then it lets you remotely control these machines right through a browser. Before, I ran them in VMware, and then I had to connect with RDP. But Proxmox, you don't have to. You just connect right through a browser. It's really nice. Yeah, I really appreciate it. It's in BCDEdit / debug settings, local. Yeah, so I used it for like workshops at Black Hat and stuff. I had this online version of our lab, so students could do these projects even when they didn't have the right equipment locally. And that worked. So, all right, now you got to restart it, but maybe I don't have to. So I'm going to try to run WinDbg preview. Oh, we're using WinDbg preview. Good, that's a whole lot nicer. I thought this might be using the old WinDbg, but if you're using the preview, then it's a whole lot nicer. Run as administrator. And this thing has been like in a beta for like 2 years. Microsoft does this, but it works really well. Even works on Windows 11 pretty well. All right, so now I do file, attach to kernel. And now I can connect to various devices, but I just want to go local, which is the local kernel of this machine. And say, okay. And if it works, it will let me in. Executable search path, I think I'm in. And I can find out by doing an LM to load modules. And there we are, dumping modules. Here's NT kernel. These are the NT kernel modules. Symbols, NT kernel mp.pdb, here's NT. So it loaded the current modules, which is the kernel itself, and then I guess these are drivers. And so it's working, good. So we did loaded modules, all right, and now we can look at the symbols. Yep, we'll see them in NT. We can use the GUI. We can use NT, and then I think we can click A. Yep, all right, so let me go there. So NT is here. I can click it instead of typing in a command, but it's kind of silly. All it's going to do is execute the command for me. It executed this lmdvmnt, which is information about NT. Here's the information. And now I could browse all global symbols, and I could also click functions. Here's a list of all the kernel functions. So I click that, and it executes this command. Now, this is why I don't know why they even bothered to make this thing a GUI, because it just scrolls off the screen and is kind of useless. It might as well just be a command line tool, in my opinion. But anyway, this gives you a list of the modules, and what you're seeing here is just the ones that start with A. And let me see if I can jump up a page at a time. Maybe this. Yeah, okay, good. There we are. That's where it starts. So all it did was type in this command, x/d/f nt bang a star, getting all the modules to start with A. And here it lets you click these letters to do B, C, D, E. So that's what they did in the way of a GUI. Instead of having to type in this command, you can click this, and then it will just dump 10 pages of junk that you have to scroll back through. So I don't really know what the point is. It's very much less user-friendly than Ollie. But it's your only way to use the kernel. And this is their new thing. This, where you can click on things, that's the new thing in the preview. But anyway, it's nicer than the old one. How do you spell Proxmox remotes or Proxmox? I'll put it in the chat. Proxmox, Proxmox. Very nice. Good. All right. So, so we can use help, local help. You don't even have to load this with a command line command anymore. There is a local help button here. And that loads the Windows 3.1 CHM file, which is what you use. Here's where you find how to use everything. And so you can go to X, for example, for examine, which is something you use a lot. There's examine, double click that, and now you have the examine command, and you have all the switches and everything. And this is where you learn what they are. So, very useful. And now you've got a flag defined by using the examine command to find a function from some information. And then you can disassemble a function. So we'll do this unassemble function for NT create file. And I got to go here and here. All right, and there we are. Nope, not letting me. My clipboard is empty. Well, that's rude. I'll just type it. UF NT bang NT create file. All right, that should unassemble the start of the NT create file function, and there it is. Looks like it did the whole thing right down to the return. I thought it would only do the first few bytes, but it did the whole thing. So that is the entire function. And this is often the case. Most of these functions do almost nothing except just rearrange the symbols and call another routine. Most of them are just sort of stubs. So this just moves a whole bunch of things onto the stack, RSP plus 78, RSP plus 70. It's just loading things up on the stack, and then it's going to call a lower level function. Whenever it goes down, there we are. It's going to call IOP create file. That's essentially what they all do. They just lay it up and call a lower level function. All right. So you can search memory. Let's see if I can copy this one. This is going to search, starting at NT create file and going for 100 bytes. It's going to search for this pattern of bytes in hexadecimal, 44, 24, 40. So There we go. And of course, you have to read the help menu to learn how to do this. There's my clipboard. Okay, good. That's weird. It's giving me some kind of graphic clipboard thing. That looks like a new Windows 10 thing. Anyway, so this is going to search, starting at that location, 100 bytes for that pattern of bytes, 44, 24, 40. And you can probably see here's 44, 24, 40 right there. That's 44, 24, 70. But there must be a 44, 24, 40 too. Let's try this command. It should find it. And there it is. A 44, 24, 40 is here. Now we can compare this address. This is FF, it ends in 1E3. So it is here. 44, 24. Yep, 44, 24, 40 right there. So one past E2. That's starting at E3 is that pattern of bytes. So you can use this to search for any pattern of bytes. And the way this happened, of course, is I was trying to reproduce our WinDbg projects using this product. I was going to like hack Minesweeper, and I couldn't find search for all reference text strings. They don't have it. What they have is this kind of stuff, which is much less convenient. In principle, you can do stuff. In fact, it's very, very annoying. Anyway, here's how you can find strings. SA will search for ASCII strings, and by default, any string of length 3 or more. So this is going to search for all the ASCII strings, starting at that location and going for 100 bytes. So I copy, and then here I paste, and this is kind of interesting. So it shows me the clipboard. Apparently I have multiple clipboards. You can paste on your other devices. So I don't quite know what's doing this. I think this is probably a Proxmox thing, because this doesn't look like a default Windows thing. Anyway, it's working. I'm just not quite sure which of the many systems I'm going through is doing that. So that should find all the strings. And as you can see, there they are. A bunch of random 3-letter strings and then one that's actually sort of readable. Those are the strings within 100 bytes, because this function doesn't have any hard-coded literal strings that make any sense. It just has bytes that happen to be ASCII characters. All right. And now here we can search length 6. This is how you specify, I only want the strings that are length 6. And like I say, again, why you really have to read the help message, because that is very far from obvious. It's square brackets for that parameter for some ungodly reason. I would have just thought it'd be like a minus L6, but it's this, minus bracket L6. So that instead of showing me all these short ones, it'll only show me the long ones, and there's only one long one. All right. And all right, so then there's another flag defined there. And then there's MemoryDB is the all-purpose one that just displays data the way you'd see it in like Wireshark or other things. It shows it to you with an address, then the hexadecimal, and then the readable text. This is the most useful way to see stuff usually. So you see what's going on here, the MZ header, and this program cannot be run in DOS mode. And later on, it will have more functionality in the kernel. All right, that's the start of the kernel. And you can examine a data structure, which we talked about in a lecture. This will show me what a file object looks like. So, file object. All right, so a file object, if I scroll up a little to get to the start. All right, it's got a device object, it's got a section object, it's got a pointer to a file object, it's got a Unicode string for the file name, and an integer for the byte offset, and so on. So these are just parameters that determine a file. And there's online web pages from Microsoft that will explain it in detail. These are quite useful. If you want to understand these things, you can just Google for Microsoft pages, and you'll find a complete description of exactly what all these parameters mean. And this is what programmers need. You learn how to use this, what values to put in all these parameters to achieve various things. So let me give it Control W. Oh, good. Control W worked. Good. I'm doing a little better at controlling this thing. So now I can do .tlist to see the currently running processes. And there they are. These are the userland processes. This is a Java update. And here's CFF Explorer that I left running and so on. So you're seeing the userland running processes. And you can find details about the LSASS process, which is the Local Security Authority subsystem that's used to handle passwords and logins. I think it is running all the time Windows is running. So it should be on that list somewhere. Maybe I can spot it. Let's see if it's too hard to look through. LSASS should be, there's Firefox, DIL hosts. Somewhere in this mess should be LSASS. There's the service hosts. It should be, WinInit should be around where I log in. There it is, LSASS. So here's Win login, and near there is LSASS because it had to use that to process the password to get in. So this will show me more information about the LSASS process. And there it gives me a little more information about it, like the parent identifier, the process parent. So you can then, it gives you a blue address for the process environment block, and you can click that to get even more information. Here's the process environment block. And when you click that, it will give you a lot of information about the LSASS process. And yeah, I don't know if there's anything too exciting here. Let's go up. There's a number of processors. There's the operating system and the path, see Windows System 32, and so on. These are like the environment variables for the process. And here's the image file, the command line to launch it, and stuff like that. So, you know, here's all the DILs it uses. So this is the same stuff you'd see in Process Explorer. It's how you could duplicate the functionality of Process Explorer in WinDbg. This will show me devices and drivers. This will show me the disk driver, I think, or maybe the disk device. I'm not quite sure. All right, so now it shows me IOP root device node, and it tells me it is a Red Hat, vendor Red Hat. And this, I think, we told you before, apparently the Proxmox must be based on Red Hat in some sense. So my machines are running on apparently Red Hat hardware, so maybe I'm wrong when I thought it was based on Debian. It seems like Debian, but maybe it's based on Red Hat. Anyway, my virtual disk is interpreted as a Red Hat device. All right, and then there's one that is for extra credit, takes people a while to find. I only give you some of the information. You have to find this and find out which function this is. And one tip I'll give you is these bytes will be the same, but this address will be different. Your module will be loaded. So you can look for these literal bytes, but beware that the address of this module may have changed. So look for these, and then that function that looks for symbols near an address will help you find the starting address of it. All right. And that's it, and you can disable debugging. Anyway, that's just playing with a little bit of this kernel debugging just so you get a taste of how it works. And I'm going to stop that recording.